Hello and welcome. My name is Dante Sidoric, and today I'll be taking you on a journey through the geologic history of Grand Canyon National Park. As you can see on the map to the right, the Grand Canyon is divided by the Colorado River into the North Rim and South Rim. That will become important later when we do a deep dive into the region's stratigraphy, both terrestrial and marine. In addition to this, we will learn about the region's volcanism, basement rocks, orogenies, paleontology, caves, glacial activity, natural disasters, historical land use, anthropogenic climate change trends, and more. The land where the Grand Canyon National Park is located today has been home to the native peoples for tens of thousands of years. The graphic on the right shows us just how many tribes are native to this land, including the Navajo, Zuni, and Southern Patwa tribes. The Desert View Tribal Heritage Project established a cultural heritage site where tribal members share wisdom with the goal of educating visitors. This would be a great place to learn how native peoples contended with natural disasters that are common to this region: flash floods, rock slides, droughts, wildfires, etc. The caves, rivers, wildlife, and many other parts of this land have been used by these native peoples for hunting, agriculture, and spiritual purposes since they began to occupy this region. The Grand Canyon's immense beauty and geological significance was part of what facilitated its establishment as a national park on February 26, 1919. However, the park's establishment was also a response to the displacement of these native populations as a result of mining, logging, and pollution. Here we see some of the earliest trails being built for tourism rather than for mining or for logging. Grand Canyon National Park's protected status has enabled extensive study and mapping of the region. So without further ado, let's start at the bottom and work our way up. As we can see from the geologic cross-sectional diagram to the right, the basement rocks in this region is called Vishnu Schist. For data acquired from the National Park Service research paper entitled Vishnu Schist, informs past geologic formation by demonstrating that volcanic island arcs collided with and accreted onto ancestral North America during the Yavapai Mazat orogeny, forming the Vishnu Mountains, which stood 6 miles above sea level. Then repeated freezing and thawing, among other factors, weathered the Vishnu Mountains to roughly 2,000 feet above sea level. The sediment resulting from all this eroded material being carried over to the ocean by wind and water made the landscape where the canyon sits today smooth and level as of 1.5 billion years ago. Although we can observe that the Grand Canyon National Park is very much a terrestrial environment today, paleontological evidence tells us that the region has previously been a marine environment on several different occasions. The sediment deposited atop this featureless plain during the succession of terrestrial and marine environments form the layers of rocks that form the cover rocks in the canyon today. According to the National Park Service, we can use our observations of ancient brachiopod, chronoid, and horn coral fossils in the Kaibab limestone, the uppermost layer of the rock of the Grand Canyon, to deduce that it formed at the bottom of an ocean, a marine environment. How are these marine fossils in a layer of the canyon so far from sea level, you might ask? Well, the answer is uplift. The laramide orogeny, 70 million years ago, caused the layer of rock to uplift in a way that maintained its original horizontality. We're now familiar with the marine and terrestrial stratigraphy of the region, but the fascinating part about Grand Canyon National Park is that this stratigraphy is visible, not simply that it exists. Geologists agree that the Colorado River is responsible for carving the Grand Canyon to reveal this breathtaking stratigraphy, but have yet to reach a consensus on exactly how it came to do so. One theory about the formation of the Grand Canyon River revolves around the Colorado River. It talks about green clay, which only forms in deep water. According to geologist Richard Young, this clay tells us that atop the flat plain that once existed where the Grand Canyon sits today, the 6 million year old Lake Bittahoche, which held a whopping 3,000 cubic miles of water, was left over from a period when the region was a marine environment. The Colorado River formed when the lake spilled over and water began rushing towards the Pacific. According to Young, we can deduce that this spillover began to carve the Grand Canyon 5.5 million years ago by observing that the marine organisms whose fossilized shells comprise the Muddy Creek limestone died 5.5 million years ago when the Colorado River muddied their freshwater lake environment. Alternatively, geologists such as John Wesley Powell or William Morris Davis theorized that rather than a massive ancient lake spillover causing the river to carve through already uplifted rock layers, the Colorado River pre-existed the laramide orogeny and was powerful enough to erode the rock it flowed over faster than the rate of uplift, eventually resulting in the formation of the canyon. Whatever the case may be, one thing we do know about the Grand Canyon is that it is warming and drying. As a representative of the National Park Service put it, at Grand Canyon National Park, increasing temperatures and changing precipitation patterns may alter park ecosystems, changing vegetation communities, habitats available for species, and the experience of park visitors. According to National Park Service, this has reduced snowpack and stream flow in the canyon area. Many park visitors also report having seen the Colorado River get significantly lower over the course of their lives. Water usage is increasing, temperatures are increasing, and precipitation rates are not increasing along with them fast enough for our current course of action to be sustainable. In conclusion, the region's stratigraphy, volcanism, basement rocks, orogenies, paleontology, caves, glacial activity, natural disasters, and historical land use are all important aspects of understanding Grand Canyon National Park. If you leave this classroom remembering nothing else from this presentation, remember this. Anthropogenic climate change is leading to devastating consequences in Grand Canyon National Park. And since the goal of a national park is preservation, we need to seriously reconsider whether the rate at which we're depleting natural resources is justified and whether we're doing enough to counteract the effects of anthropogenic climate change. Only if we do these things can we have hope for future generations to experience the Grand Canyon National Park that we see today. Thank you.